These are the notes for 2.2, solving quadratic equations by completing the square. We're going to start with the case where a is equal to 1, as with this quadratic here. We identify b and c straight away. The first thing we're going to do is halve b. That's the first thing you always do, halving b, writing that down, and then putting x in a bracket with it and squaring it. We're completing the square. That is the square. Now it's to complete the square. We are going to subtract the square of this number here. We're going to do that outside the bracket to the right hand side. So step 1 is halve b. Step 2 is subtract the square of that. And step 3 is just to carry down whatever c is. That last constant term gets pulled down and sits alongside negative 16. The very final step is to neaten things up and to add together negative 16 and positive 2. And we have it in the form of a completed square. Okay, we'll see how we use this in a minute, but next we're going to go on to have a look when a does not equal 1. Okay, so here we are, a case where a is equal to 3, so it's not equal to 1, and we have negative 24 and 5, so some horrible numbers. The first thing is we really need to notice that the 3 is there. We need to acknowledge it's there because there's a slight different beginning. We are going to take that 3 and we are going to take it out of the first two terms as a factor. So we are going to divide b by 3. We need to see this number to be able to do the work. So you're going to see brackets appear around the first two terms, and then 5 will appear just at the end. We like to leave c on its own for as long as possible and delay it until we include it with whatever constant term we have at the end. So we've dealt with the first two terms. Now inside these brackets, we're going to complete the square just as we did a minute ago on those two terms. So we're going to complete the square in the brackets. Now I've actually drawn curly brackets. I'm going to adjust that in a second. I normally use square brackets to do this. So doing square brackets is helpful because inside those square brackets, you're going to have curly brackets. So it's nice to be able to distinguish the two sets of brackets by making them look slightly more different. We're going to really show you the use of the square brackets. We're working inside those square brackets in red. Now, we don't have a constant term at the end after 16, so it's just going to be 16. The final step here is going to be to expand the square brackets using the number 3. So 3 is going to get multiplied by this square and by 16. Hello, Alan. And you see the 3 just sits in front of these brackets, and we get minus 48. The last thing, as before, is to add those two terms with c, that plus 5, being merged into the minus 48 to give us our answer. Okay, so the reason why we do this is we can solve equations using this method and leave our answers in surd form really nicely. So if you imagine our quadratic was equal to 0 to begin with, then after we've completed the square on it, it's also equal to 0. We can move that term, minus 14, across the equal sign and square root. Most importantly, we must always put a plus or minus in front of the square root to show both of the solutions to this quadratic equation. And there they are. Okay, so just to see how this works with a slightly more difficult example with the a not equal to 1, we move the 43 across the equal sign, and then we have to divide by the 3. Now this is slightly new, so we get something slightly more, Alan, slightly more difficult looking because we have a fraction. But if we square root, we still get the plus or minus in front of the square root. And one of the things we could be asked to do is to rationalise our answer, or to put it into a particular form where we don't have that nasty fraction inside the square root. So we can use our surds knowledge from the last chapter to split up 43 and 3 and multiply top and bottom by the square root of 3, and we get something that looks like this.